Okay, so in this review video, we are actually going to go over a problem that was on your energy quiz. It is problem number 14. This is one of the short answer problems that was on the back, and it deals with gravitational potential energy. So if you would like to have your quiz out in front of you while we go over this, I encourage you to do so. You should have gotten these back in your latest packet that you received from me. You should have got these back on April 27th. And if you'd like to have this out, feel free to do so. Pause the video if you need to and grab it. But number 14 is going to be set up here. We have a scenario where a small child weighs 60 newtons, and if a mother left him sitting on top of the stairs, which are 10 meters high, how much energy does the child have? So we have a little bit of scenario here. Once we've read through the problem, the very next thing is we should define our variables. So in this case, we have a small child that weighs 60 newtons. So we know that here we have weight, and weight is not mass. Remember, weight and mass are different. But instead, we have weight, which is actually a force. Remember 60 newtons? That N right there, newtons, that is going to be the unit of force. So we know that the child has a force or a weight of 60 newtons. So we can define that here. So I'm just going to fill in my variables. A weight of 60 newtons. And we said that the stairs were about 10 meters high, so we can fill that in pretty easily as well. Now, using our traditional equation, it's kind of hard to use the force to figure out gravitational potential energy if you're looking for the mass. Because we usually calculate gravitational potential energy as ham, or height multiplied by acceleration multiplied by mass. So if you don't have the mass, then we really can't figure this out, because we know the acceleration should be 9.8 meters per second squared due to gravity, but we really don't need that here, because we can use another formula that I know it's been a little while since we talked about it, but this is kind of the shorter way. It's a little bit of a trick. We can use another formula, which is basically GPE equals HF, so height multiplied by force. And we can use this because if you really think about it, Newton's second law, which is F equals ma, or force equals mass multiplied by acceleration, the nice part is if we look at GPE here, we have acceleration and mass. They're being multiplied together, which means we actually can substitute that and just make it force. So we can just skip a step right here. So realistically, there are two equations you can use to calculate gravitational potential energy. You can use the one that we started with, which is ham, or you can use GPE equals HF. So if anytime I ever give you a weight of something, I would immediately just skip over ham and I would go to this problem. It's going to help you out a lot. So we're going to use this formula. We just defined our variables, so the last thing we got to do is just plug it back into our formula. So what we have to do here is write that GPE equals 10 meters, so we'll just write 10, and then it's going to be multiplied by a force of 60, so this is some nice simple multiplication here. It should just be 10 multiplied by 60, and our final answer is going to be 600 joules. So I can see how this one would be a tricky one because we haven't talked about this formula in a while, but it is still available to you to use if you need it. Also, just make sure that you don't make the mistake. A lot of people did this, and it's okay. Make sure that if you are going to use this equation, that you have the mass. If you have the weight, you do not have the mass. They are slightly different. Mass is the amount of atoms within an object, and weight is basically the force of gravity acting on the mass. So we need to make sure that if you're going to use this formula, that you have the mass. Anytime you have weight, though, you should definitely use this. Hopefully this was helpful.